Chapter 1, Section 6 is about differentiation techniques for products and quotients. So we have previously learned about differentiating constants and the power rule and the constant multiple rule and the sum and difference rule. So now we're going to have a product rule and a quotient rule. So the product rule is let's let some f of x, some capital F of x, be equal to small f of x times g of x. G of x. Then your derivative, your f prime, is going to be the derivative of the product will be the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor, which is what this says. If you can say this to yourself while you're doing it, it'll make it a lot easier. First times derivative of the second plus second times derivative of the first. All right. For this particular example, we have y is equal to x to the 9th times x to the 4th. Well, it's easy to simplify this. It would be x to the 13th power. And then the derivative of that, dy dx, would be 13x squared using the power rule. But let's use the product rule and see if we actually come out to 13x squared. So dy dx, let's label. This will be our first factor. This will be our second factor. So the first, which is x to the 9th, times the derivative of the second. Derivative of x to the 4th will be 4x cubed, plus the second, which is x to the 4th, times the derivative of the first factor, so x to the 9th will be 9x to the 8th. And then if we go ahead and we simplify, 4x cubed times x to the 9th, that's going to be 4x to the 12th, plus x to the 4th times 9x to the 8th, it's going to be 9x to the 12th. Add them together, 4 and 9 makes 13, x to the 12th power. So it did come out the same. Okay, for our second example, we have a product of two binomials. Let's FOIL that out. So g of x would actually be 12x squared. Inners are minus 8, outers are plus 3. Minus 8 plus 3 is minus 5x. And the last will be minus 2 plus 1 will be minus 2. Then g prime of x will be 24x minus 5 and then plus 0. So let's see then when we use product rule if we come out with 24x minus 5. So g prime of x, this will be the first factor, this will be the second factor, will equal the first, which is 3x minus 2, times the derivative of the second. So derivative of 4x plus 1 is just going to be 4, plus the second, which is 4x plus 1, times the derivative of the first, which is going to be a 3. Alright, so let's go ahead and simplify. If I distribute the 4, I have 12x minus 8. And if I distribute the 3, I have 12x plus 3. 12x and 12x will be 24x. Minus 8 plus 3 will be minus 5. So it did come out to the same result. Okay, let's go ahead. We've got a product here, a binomial multiplied by a monomial. This will be our first factor. This one's going to be our second. So f prime of x will be equal to 3x to the 4th, the first, times the derivative of x squared minus 4x. So 2x minus 4, plus the second, x squared minus 4x, times the derivative of the first. So the derivative of 3x to the 4th will be 12x cubed. And let's go ahead and simplify. So we will distribute, and it's going to be plus,
and then 12x to the 5th minus 48x to the 4th is equal to 6x to the 5th, 12x to the 5th, that's 18x to the 5th, minus 1248, that's going to be 60. X to the 4th power. And if we distributed and then took the derivative, we would find that's equivalent. Problems like this can be found on page 154, numbers 1 through 12. Okay, let's talk about the quotient rule. So I'm going to have a quotient of two functions, a numerator's function, denominator function. Denominator can't be equal to 0 because then my fraction would be undefined. The quotient rule, and if you'll read this, it's much easier to say than worrying about words like numerator and denominator. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That's how you do the quotient rule. So we've got a quotient here, x to the 6th divided by x to the 4th. We can simplify that. That would be 6 minus 4 is 2. That'd be x squared. Derivative would be dy over dx of x squared is 2x. Let's see if we use quotient rule, we come up with 2x. So dy dx will be equal to the bottom, which is x to the 4th, times the derivative of the top, so 6x to the 5th, minus the top, x to the 6th, times the derivative of the bottom, so that'll be 4x cubed, all over the bottom, x to the 4th, squared. Okay, let's simplify. This is going to be 6x to the 9th, minus 4x to the 9th, all over power to a power you multiply, so this will be x to the 8th. So this is going to be 2x to the 9th over x to the 8th, canceling 8 of these with 8 of those. Whole thing is going to be 2x. So they are equivalent to each other. All right, let's try the second one. Now, if we did monomial division, then we could simplify this, and it would be g to the x is equal to 3x to the 6th minus x squared. If we rewrote that into two separate fractions and reduced each. If we take the derivative of this, g prime of x will be 18x to the 5th minus 2x. Let's use quotient rule and see if we come up with the same result. So g prime of x will be equal to the bottom, which is x, times the derivative of the top. So it's going to be 21x to the 6th minus 3x squared minus the top, so 3x to the 7th minus x cubed. Really important to use the parentheses because the minus sign has to be distributed, times the derivative of the bottom, derivative of x is just 1, all over the bottom, squared. Okay, let's simplify. So we'll distribute the x, 21x to the 7th minus 3x cubed. Distribute the minus sign, minus 3x to the 7th plus x cubed, all over x squared, which is equal to 21 minus 3 would be 18, x to the 7th, minus 3 minus, or negative 3 plus 1 would be negative 2, x cubed, all over x squared, separated into two separate fractions and reduced. 7 minus 2 will be 5, so 18x to the 5th, 3 minus 2 will be 1, minus 2x, so they are the same. Okay, here's a little more complicated one. We're not going to be able to simplify this to have a double check for our answer. So let's go ahead and take the derivative. So it's going to be f prime of t is equal to the bottom, negative t squared plus 4t plus 1 times the derivative of the top, so it's going to be 6t plus 2 minus the top, 3t squared plus 2t minus 1 using parentheses, times derivative of the bottom is going to be negative 2t plus 4 all over the bottom squared, so negative t squared plus 4t plus 1 quantity squared. Okay, now rather than FOILing this all out or multiplying this all out and combining like terms, because we have common factor here of at least 2. I can see a 2 that I can factor out of here and a 2 I can factor out of there. If I factor that out initially, that's going to make the numbers that I have to work with inside easier to deal with, smaller. So let's go ahead and do that. Be equal to negative t squared plus 4t plus 1 times 2 times 3t plus 1, so I factored 2 out of here, minus 3t squared plus 2t minus 1 times, if I factor a negative 2 out of this one, it'll be t minus 2, because negative 2 times t will be negative 2t, and negative 2 times negative 2 will be positive 4. So now in this case, all over negative t squared plus 4t plus 1 quantity squared. In this case, these two negatives are going to become positive. A negative times negative is positive. This 2 will factor all the way out front. 2 times quantity, let's use big
negative t squared plus 4t plus 1 times 3t plus 1 plus 3t squared plus 2t minus 1 times t minus 2 all over. Now if I factor a negative 1 out of this guy, it'll be negative 1 times t squared minus 4t minus 1 squared. That way I'm not leading with the negative. And then inside, we're going to have 2 times, by the time you FOIL this out and combine all your like terms, it'll be negative 3t cubed plus 11t squared plus 7t plus 1 plus quantity of, and we won't, actually, you know what, we won't need the parentheses because there's no factor up front. It will be 3t cubed minus 4t squared minus 5t plus 2 all over. If you square a product, you square each factor, so squaring a negative 1 makes them a positive 1, so the denominator is going to be t squared minus 4t minus 1 quantity squared. Now, I'm going to need an extra piece of paper here. Let's go ahead and combine these like terms. So this will be equal to 2 negative 3t cubed, positive 3t cubed, those are canceling. 11t squared minus 4t squared, 11 minus 4 would be 7t squared. 7t minus 5t will be plus 2t. And 1 plus 2 will be plus 3. All over t squared minus 4t minus 1 quantity squared. And at this point you can leave it like this, or if you choose to distribute, that will be 14t squared plus 4t plus 3, 6, all over t squared minus 4t minus 1 quantity squared. Problems like this will be on page 154, numbers 13 through 20. Again, to simplify as much as possible, factor your numerator and reduce if you can. We tried. There was nothing we could cancel with our denominator, but at least we got our numerator as condensed as possible. All right, so this is a problem where we're going to use rules together. We're going to use quotient rule. We're going to use the sum and difference rule on this particular problem. So if we're differentiating f of t is equal to t over 5 plus 2t minus 2t to the fourth, then f prime of t will be equal to product rule. So bottom times derivative of the top minus top times derivative of the bottom all over the bottom squared minus the derivative of the second term would be 8t cubed. Okay, let's simplify this up a little bit. Will be 5 plus 2t minus 2t all over 5 plus 2t quantity squared minus 8t cubed, which is just going to be 5 over 5 plus 2t squared minus 8t cubed. Problems like this can be found on page 154, numbers 21 through 48. All right, let's talk about something a little bit different. Since the cost, revenue, and profit per items varies, because these are not linear functions, an average is going to be used. An average will be the total divided by the number of units. So your average cost, revenue, and profit functions look like this. If C of X is the cost of producing X items, then the average cost of producing X equals A items is going to be the cost of all A items divided by the number A, which is how many items there are. And the average cost function will look just like this. Average cost function of X is equal to C of X divided by X. Revenue function and profit functions are not going to be any different. All the rest is the same. The average revenue function will be
revenue divided by, or actually, this is the in general, and this is the specific. So if X is equal to A, for A items, it'll be revenue from A divided by A items, and the actual average revenue function in terms of X, so that we can use any value, any number that we want of items, will be R of X over X. And profit function, the same thing. If I know how many items I'm dealing with, A items, then it's going to be profit of the A items divided by the A number of items. And as far as producing a function so that I can just keep plugging in numbers for a different number of items, it's going to be profit function divided by X. Okay, so then the cost in dollars of producing X bottle of barbecue sauce is given by C of X is equal to 375 plus 0.75 X to the 3/4 powers. Find the average cost function, so this is in general. Then find the rate at which the average cost is changing when 81 bottles of barbecue sauce have been produced. Okay, so the average cost function, we're going to have to take our cost function, which is 375 plus 0.75 X to the 3/4, and divide it by X. Okay, and if we wanted to separate that into two separate, it'd be 375. You know what, let's leave it, because we need practice with our quotient rule, and it's asking us for the rate of change. That means we have to do the derivative. So the derivative of our average cost function will be the bottom times the derivative of the top. So 3/4 times 0.75 is 0.5625. X to the 3/4 minus 1 will be negative 1/4. Minus the top, which is 375 minus 0.75 X to the 3/4 times derivative of the bottom, which is just 1, all over the bottom squared. Okay, so that's going to be equal to X times 0.5625 X to the negative 1/4 power, be 0.5625 X to the 1 plus negative 1/4 is 3/4, minus 375, minus minus is a plus, 0.75 X to the 3/4, all over X squared. Combining like terms, negative 0.1875 X to the 3/4 minus 375 all over X squared. Okay, there's the average cost function. Now the rate of change for the average cost function. So then let's go ahead and evaluate that for 81. So A prime for the cost function of X is going to be equal to negative 0.1875 times the 81 minus the 375 divided by the 81 squared. So we plugged 81 in for X here and here, and that is approximately negative 0.0579 dollars per bottle. Okay, so your cost function, the rate of change for 81 bottles is actually decreasing by nearly 6 cents per bottle. The revenue in dollars from the sale of X bottles of barbecue sauce is given by this function. Find the rate at which the average revenue is changing when 81 bottles of barbecue sauce have been sold. Okay, so then we need an average revenue function. So average revenue function would be 7.5 X to the 7.7 over X, okay, which is going to be equal to 7.5 X to the negative 0.3, and the derivative of that function, which will give me the rate of change, is going to be negative 0.3 times 7.5 is negative 2.25, x to the negative 1.3. And when we evaluate this for 81, negative 2.25, 80 times 81. Let's fix this up before we keep going here. We're evaluating now, so we need to replace the x with the 81. Then it has to be 81 raised to the negative 1.3 power, which is approximately negative $0.0074 per bottle. So your revenue, change in your revenue is actually decreasing by nearly a penny a bottle at 81 bottles of barbecue sauce. So then let's go ahead and talk about the profit. Using the information from the previous two examples, find the rate at which the average profit per bottle of barbecue sauce is changing when 81 bottles have been produced and sold. So then the average rate profit will be the revenue minus the cost. And since we already know we're doing it at 81, revenue of 81 minus the average cost of 81 will be equal to negative 0.0074 minus negative 0.0579, which is dollars per bottle.
So at 81 bottles, our cost is going down faster than our revenue is going down. Therefore, our profit's actually increasing by nearly a nickel a bottle. Okay, problems like this can be found on page 154, numbers 53 through 63.